Hi everyone, welcome back to the channel. Today I'll be covering types of numbers, HCF and LCM from the numbers chapter of IGCSE Mathematics, subject code 0580. So first off, we will be covering the types of numbers. On the right hand side is an image that will summarize everything we'll be covering under this subheading. So there are a few that has to be known, and the first one we'll start off with is natural numbers. So natural numbers are also known as counting numbers, and they include 1, 2, 3, and so on. Then we have whole numbers, which is basically natural numbers and 0. So it would be 0, 1, 2, 3, and so on. Thirdly, we have integers. So integers are the negative values of whole numbers. So that would be -3, -2, -1, 0, 1, 2, 3, and so on in both directions. So integers can be positive or negative, and 0 would not have a negative because 0 is simply 0. Then moving on, the next part we'll be covering is rational numbers. So to start off, rational numbers. So the term rational is derived from the word ratio. This implies that numbers can be written as ratios or fractions. So for example, we have 0.7. This can be written as 7 upon 10. And you'll notice that 7 upon 10 is in fact a fraction. Now this takes me to my second point, where you can imply that all fractions are rational numbers. But there's one important thing you should know, is that not all rational numbers are fractions. So what I mean by this is, well, actually first we'd have to define what exactly a fraction is. So fractions can be written in the form p by q, where p and q are integers, q is not equal to 0, and q does not completely divide p. For example, we were given the number 9. So 9 can be written as 9 by 1. We know 9 is an integer. When we write it in a so-called fraction form, where we have a denominator and a numerator, it would be 9 by 1. But you'd realize that a 1 can completely divide 9 to give you 9. It does not give you a decimal place, it does not give you reoccurring decimals, and so on. So that's why in this case, 9 as a rational number is not a fraction. Let's say we're given another example. For example, 3 by 4. We know this is 0.25, and we know 0.25 can therefore be written as 3 by 4. So because of that, 0.25 is a rational number, and 3 by 4 is also a fraction. So 3 by 4 can be a fraction and a rational number, and 0.25 is only a rational number. Some other examples can include, for example, 1.5. 1.5 can be written as 3 by 2. That's why we can consider 1.5 to be a rational number, because it can be written in the form of a fraction. Now, we know for sure that 3 by 2 is a fraction because 2 does not completely divide 3. 2 is not equal to 0, and both 3 and 2 are integers. In the same way, another example would be 0.333 and so on. This can be written as 33 by 99, and that is equal to 1 by 3. Now over here, 1 is not completely divisible by 3. You end up getting a decimal place, a reoccurring decimal to be more precise, and 3 is not equal to 0, and 1 and 3 are both integers. So it's a fraction and it's a rational number, and 0.333 is a rational number as well. So moving on from rational numbers, you have irrational numbers. This one is a bit simpler because in this case, these are all numbers that cannot be written as fractions. And I think the best way to know it is through example. So irrational numbers cannot be written as fractions. And examples are root 2, root 5, pi, which is 3.14159, and e, which is 2.71828, and you can have many more examples for irrational numbers. They're basically numbers that cannot be written in the form of fractions. After rational numbers, something else that is included in the syllabus is square numbers, cube numbers, prime numbers. So square numbers would be, for example, x squared. Now, what exactly does x squared mean? It means x into x. This tiny dot over here implies multiplication. So the difference between x squared and 2x is something that is often confused. 2x over here means 2 into x, or it can be x plus x. In the same way, if we had x cubed, that means x into x into x. But if we had, for example, 2x cubed, what would that mean? You can pause the video to try and figure it out. So I hope you tried attempting it, and I will explain what it means. It's basically 2 into x into x into x. So the reason why I explain this is because people usually get confused between powers and multiples. Where on the left hand side over here, we were talking about powers, but on the right hand side, we were talking about multiples. So when it comes to square numbers, there are certain square numbers you should know. For example, 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25, 6 squared is equal to 36, 7 squared is equal to 49, 8 squared is equal to 64, 9 squared is equal to 81, 10 squared is equal to 100, then 11 squared is equal to 121, and finally 12 squared is equal to 169. So I'd suggest memorizing all of these values so that it's easy to work with and easy to identify. And I hope you're aware that the opposite of squaring is square root. So for example, if I had 7 squared is equal to 49, I know that the root of 49 should equal to 7. So after square numbers, we have cube numbers. This is square numbers, where x cubed is basically x into x into x. So I would suggest knowing the values of 2 cubed, which is 8, 3 cubed, which is 27, 4 cubed, which is 64. Then you have 5 cubed, which is 125, 6 cubed is 216. But I guess the most relevant ones would be 2 cubed, 3 cubed, and 4 cubed. So after cube numbers, we have prime numbers. And prime numbers are something we've been taught since primary. And prime numbers are basically, by definition, numbers which are only divisible by 1 in itself. So for example, we had number 2. We know the factors of 2 can be 1 and 2 because 1 into 2 is equal to 2. Same way for 3, it would be 1 into 3. For 4, we could have 1 into 4 or 2 into 2 to give us 4. So we can consider 2 to be a prime number, 3 to be a prime number, but not 4 because it is also divisible by 2 instead of 1 and itself, which is 1 and 4. The same way, for example, we had number 5. That is 1 into 5, and there is no other forms of multiplication that can give us 5. Therefore, 5 is a prime number. With 6, it can be 1 into 6 or 3 into 2, so 6 is not a prime number. 7, it's 1 into 7, and that's it, so it's a prime number. 8 can be 1 into 8 or 4 into 2, so it is not a prime number. Now, one question to think about is whether 1 is a prime number. I suggest pausing and thinking about it for a bit and then checking out the answer. So I hope you try thinking about it. And we know that 1 can only be formed from 1 into 1 in terms of multiplication. So it's true that it is divisible by 1 and itself, but the definition of prime numbers saying that it's divisible by 1 and itself basically implies that it must have two factors. But over here, the factors of 1 are 1. So we only have one type of factor here. Therefore, 1 is not a prime number. So prime numbers you should know are 2, 3, 5, 7, 11, 13, 19. After prime numbers, we have something known as reciprocals, which is basically so in reciprocals, by definition, it is one pair of numbers when multiplied together gives 1. So the definition, I'll just write it down over here. So let's say over here we were given 2 by 7. So to write the reciprocal of this, essentially what you have to do is flip the fraction. So the denominator will come in place of the numerator, and the numerator will move down to where the denominator is. So the reciprocal would be 7 by 2. Now, if you did 2 by 7 into 7 by 2, which is following what the definition implies, you would get 14 by 14, which is 1. In the same way, if we had, for example, 3. Now, you should know that integers can be written in the form 3 by 1. So the reciprocal of this would be flipped, so 1 by 3. Now, if I did 3 by 1 into 1 by 3, I'd be getting 3 by 3, which is equal to 1. So that is our definition for reciprocals. Okay, so now we'll be covering HCF and LCM, but before I go into that, there are some basic terms I have to explain. So let's say we have 1 into 6 is equal to 6, and then 2 into 3 is equal to 6. So in this case over here, let's take 2 for example. A multiple of 2 is 6. And then factors of 6 are 6, 1, 3, and 2. The reason why I say factors of 6 are 1, 6, 2, and 3 are because those two have to multiply to give me 6. And the reason why I say 6 is a multiple of 2 is because 2 is multiplied with something to give me 6. So to explain what HCF and LCM is that HCF is highest common factor. So we'll be working with factors, which is basically everything on the left hand side. And LCM is lowest common multiple. So we'll be working with multiples, which are basically our products. Now, there are two methods of finding out HCF and LCM, and that is by listing all of the factors and all of the multiples of the numbers you're working with. So I can give you an example of 12 and 18. So I know that the factors of 12 can be 1, 12, 6, 2, 3, and 4. And the factors of 18 can be 1, 18, 2, 9, 6, and 3. So you'll see that the common factors over here would be 6, 3, and 2. So out of this list, the highest common factor would be 6. So the HCF of 12 and 18 is 6. In the same way, if we had 12 and 18 and their multiples, we'd have 12, 24, 36, 48, and for 18 it would be 18, 36, 54, and so on. So from the list of multiples over here, the least common multiple would be 36. So the LCM of 12 and 18 is 36. Now this method is quite time consuming, so instead I will show you a method by division that could be easier. So on the left hand side we'll do HCF, and on the right hand side we'll do LCM, and we have our numbers 12 and 18. Okay, so over here the way this works is that we have to pick out factors that are common between 12 and 18. So the common factor between 12 and 18 would be, for example, 2. You should notice that immediately because you'll see both of them are even numbers. So when you divide 12 by 2, you get 6. When you divide 18 by 2, you get 9. Then this is also divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 9. And now you see that there is no common factor between them. So you have to continue your division with, for example, we'll start with 1. So 2 by 3 is not divisible, so we just leave 2 as it is, but 3 by 3 is divisible to give us 1. And then with 2, 2 by 2 will give you 1, and we wouldn't do 1 by 2, so we just leave it as 1. So now the LCM would be the product of all of this. So the LCM would be 2 into 3 into 3 into 2, which is 2 into 3 is 6 into 6, which is equal to 36. And that is true from the list we mentioned above. Now for the HCF, we had 12 and 18. So the same way, we'll pick out the common factors. So it will be 2 to give us 6 and 9. And then it would be 3 to give us 2 and 3. And now the difference between HCF and LCM is that you would stop where you cannot find any more common factors. So in LCM we continued by dividing further in this step where we did 3 divided by 3 to give 1, and we didn't do 2 by 3, we just wrote it as 2 in the next step, and then we did 2 by 2 to give us 1. So in HCF instead, we stop where we did not have any more common factors, and the HCF of the two numbers would be the product of the factors on the left hand side. So the HCF would basically be 2 into 3, which is 6, which is true from the list we mentioned above. That will be it for this video. I hope you understand. If you have any questions or doubts or anything that needs solving, please leave them in the comments below. If you find this video helpful, consider liking and subscribing.